So up until now, we've been solving systems of equations with two variables, which means you have two equations and two variables. Now I want to show you what it would look like if you had three equations and three variables. So that's what you have here. You've got m, n, and p that are all things that you're trying to solve for, and you've got three equations to work with. Now, what's really nice about the way this is set up is you've got one equation here with all the variables in it, and then you've got two more equations. This one is solved for p, and this one is solved for m, which makes this really easy to do substitution with. Which, remember, substitution is where you would solve for one of the variables first to begin with. So what I'm going to do with this one is I'm going to take what p is equal to and plug it in up here for p. And then I'm going to take what m is equal to and plug it in up here for m. And so here's what that's going to look like. It's now going to say 3 times what my m value is, which is n plus 11, minus 4n, minus 2, and then I'm going to put in for p, negative 2n minus 2, and have that be equal to 16. Okay, so I did substitution just like we've always done substitution, but I'm plugging in two things at the same time. But what's nice, what you'll notice now, is that this whole equation just has n's in it. Okay, so it's all one variable now. So now I can solve. I'm going to go through and first I want to pick, let's see. I'm going to distribute that 3, so that's going to give me 3n plus 33 minus 4n. And then this, remember this is a negative 2 when I distribute it. So that's going to give you a positive 4n and a positive 4 equal to 16. Now let's combine our like terms. So I'm going to combine 3n, negative 4n, and positive 4n. Well, actually, negative 4n and positive 4n just cancel each other out, so that leaves me with 3n. And then I can combine 33 and 4 and get 37. Equals 16. All right, let's subtract the 37. Subtract 37. Well, I believe that's going to be 21. Yep. So 3n now equals 21. I'm running a little short on space here, but that would mean that if I divide by 3, n is equal to 7. Okay, so that's my first answer. Now I still do need to go back and find p and m, but what's nice is I've been given these equations that are already solved for p and m. So in the p equation, I can say p equals negative 2 times 7, because I have my n value as 7, minus 2. So let's see, that's going to be, get rid of that arrow a little bit, negative 14 minus 2. Oh, I made a mistake somewhere. Oh, here it is. 16, down here. Sorry, down here. 16 minus 37 is negative 21, which makes this a negative 7, which makes this up here a negative 7. I knew something wasn't working right. So negative 2 times negative 7 makes positive 14, and 14 minus 2 is 12. So my p value is equal to 12. And then for n, my m value is equal to n plus 11. So m is going to equal negative 7 plus 11. And negative 7 plus 11, let's see, a little cramped on space, is 4. So my m value is 4. So now I have all three of my variables. I have m, n, and p. You don't have to worry about writing these as a coordinate. I would just leave my answer like this. I would say m equals 4, n equals negative 7, p equals 12. Now, I will confess, that one was set up really nicely for you. Okay, it was set up where these two equations were already solved for one variable, and they only had one other variable in them. That's all we're really going to focus on right now at this level, is these nice easy ones. These ones with 3 variables can get very complex, all right? So they could get a lot harder than this, but we're just getting our feet wet here. So give that a try. There is one of those on your homework tonight, so you'll want to give that a shot. And it's very convenient like this one. It's very much set up so you can do substitution really easily. So hopefully that made sense. We can go over it in class tomorrow if you need it.